All right, we're going to continue with 10.1. We're going to do a hypothesis test. So a national study of athletic trainers surveyed random samples of 1,679 high school freshmen, 1,366 high school seniors in Illinois, and they showed that 34 of the freshmen and 24 of the seniors had used anabolic steroids. Do the data give convincing evidence of a difference in the proportion of all Illinois high school freshmen and seniors who have used steroids? Excuse me. State appropriate hypotheses for a test and carry out the significance test at alpha equals 0.05. So we do our phantom. Proportion, our first proportion, P sub F, is a proportion of all freshmen who have used steroids. All freshmen. That's the key there. Or you can put the true freshmen. And then the same thing for seniors. P sub S is the proportion of all seniors who used steroids. So our null is that they're equal, or that P sub F minus P sub S equals 0, which is the same thing, or they're not equal is the alternate hypothesis, and their difference would not be equal to 0. Now, we used pooled for proportion tests, not for confidence intervals. So pooled means we just put them together. So it's one big fraction, 34 plus 24 over 1679 plus 1366, and we'll use that a little bit later. So now we check our assumptions and conditions, same as before. It's random. It said that it's random right here, random samples. Clearly 1,679 and 1,366 are less than 10% of all freshmen and seniors respectively. I think that's a good bet. And then we do our N times P and all that to see if we're approximately normal. So this is N times P hat or S or P hat F, N times P hat or 1 minus P hat F, N times P hat S, N times 1 minus P hat S. They're all above 10, so it's approximately normal, and we can continue. It is a two-proportion z-test. So here's our formula. It's our point estimate, which is the difference of the two proportions, the p-hats, the real p-hats, minus 0, because we're checking to see if they're equal to 0. That's our parameters. Divided by, and this is where we use the pooled proportion. So the combination of the two, the 0.019, is what we use for the numerators here, but we use the two different sample sizes for our denominators. That's our formula. When we put it in our calculator, it's nasty, but we get 0.538863. I run it to 0.539. To find the p-value, it's 2 times the probability, and it's 2 times because it's two-tailed, it's not equals. 2 times the proportion of z is greater than 0.539. Again, this is greater than because it's a positive test statistic, which is our z-score. It's positive, so we check greater than. We get a p-value of 0.5899. How do we do that? We use norm CDF, so 2 times norm CDF of 0.539 to our version of infinity is that p-value. Obviously that p-value is not less than alpha of 0.05, so we fail to reject. We have insufficient evidence to reject the null, ergo we cannot support the claim that the proportion of all freshmen who use steroids is different than the proportion of all seniors who use steroids based on our sample at alpha equals 0.05. So insufficient and cannot because we failed to reject. Now we continue to the back, interpret the p-value. P-value is the 58.99, so there's a 58.99% chance we get 34 out of 1679 freshmen and 24 out of 1366 seniors, so our samples, who use steroids if the two proportions are the same. So if the null is true. So it has to be in context. Type 1 error means that we rejected the null and we went with the alternate hypothesis. So we concluded the proportion of seniors and freshmen who have used steroids are different from each other. So that's our alternate hypothesis, when really the true proportions are the same. That's our null. So what we're saying is we think H naught is true when really our HA is true when really H naught is true. Now type 2 error is just the opposite. We say that the null is true when really the alternative hypothesis is true. So we concluded the proportion of seniors and freshmen who have used steroids are the same as each other. That's our null, when really they are different. That's our alternate hypothesis. What kind of error could we have made? Type 2, because we said we went with the null because we didn't reject it. Pretty much it. So using your calculator to find the confidence interval. So confidence intervals, we did this the other day. Two proportion confidence intervals, and then we just type in our numbers. 34 over 1679, 24 over 1366. There's our lower bound and our upper bound. Find it on this calculator, stat, not two proportion z-test, two proportion z-interval, so letter B down here at the bottom. We type in our data, calculate, and we get the same thing. So we are 95% confident the true difference in proportion of freshmen who have used steroids and seniors who have used steroids is between negative 0.07 and 0.012 based on our sample. Notice 0 is in the interval. So we would fail to reject if we were using this as a hypothesis, which is what we got anyways. So it all matches up.